और भाई कैसे हो? संडे है, सुबह सुबह जिम मार लिया भाई। अब करते हैं लीड कोड क्वेश्चन. What do we have today? We have a number of paths with max score. What do we have given? Let's read the problem statement. We have given a square board of characters. We can move on the board at the bottom right square. Okay, we will start from this one, right? We'll start from the bottom corner. So let's say this is our board from where we'll start. So we need to reach here. So this is where we have to reach. And what's given? This will be marked as E, this will be marked as S, and the rest of the characters will be numeric like 1, 2, 3, 4, 5, 6, 7, like any value from 0 to 9 basically. Okay. What do we have to return? We have to return two integers A, B. What it will contains? The maximum sum of numeric characters you can collect. Okay, maximum sum. Second will be number of paths that led to maximum sum. Okay, this is very standard DP question, I think. X is obstacle. X is obstacle. And what are our movement directions? Did I miss something? Okay, this way. We can go up, we can go left, we can go up left. Either we can move this way, we can move this way, or we can move this way. So I think this is very standard DP question. Let's do a work. So we have given E, we have given 2, we have given 3, we have given 2, we have given X, we have given 2, it's 1, 2, S. So let's see if I start from here, what do we have initially? Right, the sum will be 0. Let's say this is a number of 1. Right, the number of paths basically. If I am at this position second, what will be my sum? 2. What will be my number of paths? 1, because the number of paths still 1, right? If I at this position, what my sum? 3, number of paths will be 1. Okay, right, now we have 1. So from right, if I see from this position, right, from which cell I can reach to this one, or I can come from this one, or we don't have anything here, we don't have anything here. So from bottom I can come, right? So what will be the value? The value will be 2 comma 1, right? One path that leads to it plus what is the maximum sum here, right? 2, that is the sum of the current cell. Okay, here, right? It's x, so it will become 0 comma 0, simple, right? It's an obstacle because we cannot traverse through this cell. So if we come to this one, so we can either come from there or we can come from here, right? Or we can come from here. From here it will be 0. From here what are we getting? 2 comma 1. From here what are we getting? 3 comma 1. So right from this we are getting the maximum cell. So we'll consider this one. So we'll get 3 comma 1. Okay. Now what's at this position, right? At this 3. We can come from this side, this or this. We don't have this, we don't have this. So it will become simply plus, right? 5 comma 1, right? There's only one way. Okay. So what it becomes, from bottom it comes 0, from there it's 2 comma 1, from there it's 5 comma 1. So which path gives the maximum sum, right? This 5 gives the maximum sum. So it becomes 5 comma 1 plus 2, right? 7. It becomes 7 comma 1. So at this end, right, we have three ways, this one and this one. Which one gives the maximum score, right? 7. So we'll take this one, 7 comma 1. So this is the answer, right? 7 comma 1. So this is very standard DP question. We will first, right, for a matrix we'll start from bottom, we'll go up, and what do we need? We only need a DP, right? State that only two rows we care about, right? Let's say if I'm at any ith row, right, I only care about I plus one throw, right? I don't care about this one, I don't care about anything below this. So we need this one. So we'll need a 2D array, let's say DP array we need. And same we, right, we need to contain two things. First is path, other one is path sum. So let's say we are going to say path and path sum. These are the two things that we are going to need. Then I think it's very standard. So the time complexity will be, right, you see this, we are only traversing it once, so n cross n, right? The what is the dimensions of the board? So that will be our time complexity. Space complexity will be of n, because we are going to use this DP. So yeah, let's go and see this implementation. We are going to use DP here. What do we need? We initially need the, right, the m, we need the board dot size since it's a list, right? Then we need to initialize the two things, the path and the path sum basically. We also need one modulus, right? Let's say long, let's do long mod equals to 1 and 7. Then we need, right, the DP we need. So we'll do long star path, right? That will be the number of paths that we do. New long what its size will do m plus 1, then long star. Then we need, right, path sum, what will do new long of m plus 1, right? Then for base case, right, for the last row, what are we are going to do? We are going to loop, right, basically for and I equals to what? M minus 1, m greater than 0, right? I minus minus, right? So if my char, right, if there is an obstacle, right, we first need to get, right, char sequence to what board dot get at last row and what char at what ith position, right? And if c equals to x, right, then right everything will become zero. Path is zero and path sum is zero because now there's no path. So we'll simply break out of the loop since the default value is here zero, right? Default value equals to zero, let's say. Okay, so if it's not x, right, then if x equals to x what? If it's the char, right, c equals to what? Initial position, right, s. Then what do we do? Then paths, right? Path. This is the edge or bottom, what, bottom right basically. And path of I becomes one, but there's no path sum, so we'll do just continue. Otherwise, what we are going to do, right? Path of I equals to always one L, right? That's always one because there's only one path that's come from left side. Okay. And second is what? Path sum of what? What's my path sum? Path sum of I equals to what? Path sum of I plus 1, what I'm getting from the left, plus what do I have current, right? C minus 0. I think this suffice. Okay. Now what do we have to do now? Now we have to traverse our, right, let's say traverse our board, and we'll start from bottom. For int equals to m minus 2. Why m minus 2? Because we already did the last row. Then we are going to do I minus minus, right? Then what do we need? We need the current basically, right? Since we have a path sum from the bottom and number of paths from the bottom, so we also need for the current, right? So we need two more here, right? Let's say long current path. We'll say current path equals to what? New long m plus 1. Okay. Then long star current path sum equals to what? New long m plus 1. Okay. Then again what we are going to be j equals to what? M minus 1, j greater than equals to 0 and j, right? So we again need the char c equals to what? Board dot get what? I throw, right? Dot char at what? Which position? J position. Right? Then if right, if our c is x, right? If it's an obstacle, we are going to continue. No update, right? No update to current basically. And if c equals to what? End position. Then okay. If c not equals to what? If c is not end position, right, then what we are going to do? To the current path sum, we need to add the cell value of the current, basically, the current numeric that we can call it. Current path sum of which, what? J, right? What it will do equals to, what it will become? C minus, I think C minus 0, right? Okay. Now, we only care about the maximum path sum that we can get from all three sides, right? Let's say, what do we have? Bottom, what do we have? Bottom right, then what do we have next is only right. So let's do long max path sum equals to what? Math dot max, right? First is bottom position, right? Bottom is simply path of j, comma what? Math dot maximum of which side? Max will be what? Right side, right? Right side will be what? Current path sum of it. Okay, it's maximum, so we need path sum, not path, right? J plus 1. Current we need right? The current side basically. Then we need the bottom right, that is path sum of j plus 1. Okay. So now what do we have? Now we have the path sum basically, right? Next, what we are going to do? Next, what do we have to do? Next, we have to check if bottom side, right? If the path sum I am getting from bottom, right? If it equals to max path sum, right? Then what we are going to do? Okay, we have to add this max path sum as well, right? Current path sum of, right? Current path sum of j equals to what? Current path sum of j plus max path sum, right? Whatever the max path sum, we are going to add it. Then if, right, the path sum of j, right, what we are getting from bottom, if equals to the max path sum, it's going to contribute to the number of paths basically, right? So what we are going to do? Current path of j equals to what? Current path of j plus what? The number of paths that I'm getting from bottom, right? Okay. Next will be what? Bottom right. I will do what? Path sum of j plus 1 equals to max path sum. What we are going to do? We are going to update this one also. It's just copy paste this one. Right. Current path of j. Right. What is path of j plus 1? Okay. Next is what? Right side. Right. So what we are going? Oh shit. Right. What do we have for the right? Right. If its current path, right? It's current, if current path sum of j plus 1 equals to max path sum, then what we are going to do? We are going to again update, right? This one. Current path of j plus current path sum of j plus 1, basically what I'm getting from the right side. Okay. Okay. So I think we are good here, right? Then in the end, what we are going to check, if, like, if the paths equals to 0, right? If paths of 0, right? There are no, okay, we have to update this, all right? We have to update our path with the current path, and we have to update pathSum equals to current pathSum. Okay, now we updated our paths basically. And if there's no path, then we don't care about pathSum, right? So we do if path of 0 equals to 0, what does it mean? It means, right, the pathSum is also 0. PathSum of 0 equals to 0. Then what do I have to do? Return new empty, what we are going to return? What do we have to return? We have to return the maximum sum, right? We have to return pathSum of 0 comma path of 0. And does it seem correct? Okay, let's see if we have any problems now. Okay, the first is possible logic configuration from long to end. Okay, let's do end. Let's do end. Okay, all three are wrong. Let's see. First is the expected is 7 comma 1, and what do we get 7 comma 7? Did we did anything wrong here? Current path equals to current path. Okay, I think this is this wrong? It's current path, not current path sum. We update to the path sum. We take path, 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 and let's see. Okay, test has run successfully. Let's submit. Yeah, good. And let's analyze the time complexity as well. So it's basically O fan square, but let's see what the AI lead does for us. Okay, excellent optimization using rolling arrays. Excellent. Nice. Thanks. Excellent code, clean, well structured. So this is very important for the interviews, right? The code we write should be readable. It should not like key. Well, see, in competitive programming, we use like variables A and B, and it's fine. But when we explain it to interviews, it should be clear what does a variable mean sometimes. It's fine if you can explain it very well, like if you are in professional, you can easily do it. But otherwise, if you are just taking the interviews in the beginning, just make sure to name your variables that's easy to remember, and you basically know by variable name what does it mean. It's one of the best software practices that we do in our software industry. Okay, thank you.